Thank you. Uh, Good afternoon. Welcome to Edu Infinite Maths classes, grade 12. Now, in the last class, we started with basically, I started with the inverse trigonometric function and thereby the differentiation of that type of function. And also came to know where to substitute, how to substitute, what is the logic behind the substitution, all these things are there. I'm not claiming that we have finished the inverse trigonometric function. We just came to know, we just clarified the concept up to that level so that we can go for the differentiation of the inverse function. And thereby we have done few of this thing. Today, let's do one such thing, just for recap, very similar function. And after which, we will enter into something else. Just write down this sum. Differentiate with respect to differentiate this with respect to tan inverse 2x by 1 minus x square. Now, I'm expecting that you will give me some input for that and you will help me rather. And second thing, how do I express this? And if we express that only, what type of function do you feel? So obviously I will be taking, let this be y and let this be z. Let y be equal to tan inverse 3x minus x cubed by 1 minus 3x square. And z is equal to tan inverse 2x by 1 minus x square. Obviously, you have to convert that, then you have to find dy dz. Now, first of all, after this conversion, when I write this to be y and write this to be z, first tell me what type of function is this at present at this stage, number one. Second, you have to tell me what is the correct substitution for that, if you need any substitution at all.
So the correct substitution can be x equals to tan x.
X is equal to tan theta. Very good.
Tan theta. Then tan inverse that will become tan 3 theta.
Very good.
So then y will be equal to 3 theta. So then
And z is equal to
2x. So we can do x equals to tan theta again. Then that will become tan 2 theta.
right. So
Z will be equal to 2 theta. Then first we will do dy d theta, then dz d theta, and then divide them.
very good. Achha, just one question. When I write this, it is what type of function? Is it explicit, implicit function? It will come under that, or any other classification? What kind of presentation is this? What kind of function I have converted? Y in terms of x, z is also in terms of x, I have to find dy dz. This is parametric. Apparently it doesn't seem to be a parametric one, but when you write it in this form, it is both y and z are expressed in terms of the parameter x. And you are absolutely correct, that put x is equal to tan theta. Now, I cannot put x is equal to tan theta out here and x is equal to something else. I have to put x is equal to tan theta everywhere. As we told, y is equal to tan inverse 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Tan inverse 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. The inside one within bracket is nothing but tan 3 theta. That is equal to tan inverse tan 3 theta. That comes to 3 theta. On the other hand, if we make the same substitution, we have to make the same substitution. Z is equal to tan inverse 2 tan theta over 1 minus tan square theta. That is tan inverse tan 2 theta is equal to 2 theta. So out here, y is equal to 3 theta. So theta is equal to y by 3 from the first, and theta is equal to z by 2. So therefore, y is equal to 3z by 2. Straight away, dy dz is equal to 3 by 2. Now, usually what happens? Usually I go for dy d theta, then dz d theta, then dy dz. Out here, I think it is much easier also when I express y in terms of we can establish the relation between y and z. It is easy to get it very quickly. Is it clear? Thank you, thank you. That is, shall I have it?
Yes, sir.
Okay. Now, the next part, in fact, this is something which we were doing in the last class. Now, today, we'll do something else. Just one step ahead of that mechanical differentiation. That is, although in some books it is written as successive differentiation, but we call it, in fact, we will restrict ourselves in second order differentiation. In fact, when you go to the higher classes, that time we will come to know that is nth order. In that case, that is successive differentiation. There is a famous contribution of the great mathematician Leibniz theorem is there. But out here, we don't go for that. We just restrict ourselves in second order derivative. What is second order derivative? It's absolutely easy. I mean, just one step ahead, as I told you. And I also told you that, number one, in normal first order differentiation, what we have to do? The differentiation takes place in one step. Rest of the steps, simplification, mainly simplification. And most of the times you will find nowadays, and we have seen that also in the papers, so we go through the question papers, you will find that in differentiation problem, mostly you will be asked to arrive to a conclusion. If this is equal to this, prove that something where dy dx is involved is equal to 0 or is equal to 1 or is equal to something. Usually, find dy dx of when y is equal to that is, it is not asked. So basically, it is a problem of differentiation takes place in one step, that is by the formula. But rest of the steps are basically algebraic treatment or trigonometrical treatment. Out here in the second order differentiation, you have to do it twice. What is that? If ddx, if we take differentiate dx of dy dx, it becomes d2y dx2. d2y dx2. If we differentiate, say, I'm talking about y is equal to x, x to the power 4. dy dx is how much? 4x cubed. And if we differentiate for the second time, therefore, d2y dx2, basically ddx of this thing, which is equal to square root of x squared. Similarly, d3y dx will be 24x. Therefore, y dx4 will be just 20. Now, as you know, this is also known as this dy dx. dy dx is also written as f dash x, or sometimes same as y1. y1 also stands for dy dx. Similarly, d2y dx2, that is second order differential, if w dash x, or we express as y2, it's all the same thing. It's all the same thing. And if you get f dash says 0, it means the value of dy dx when x is equal to 0. Now, in some of these sums, there is a certain pattern. While doing the sums, we'll find it out. But we'll start with comparatively easier sum. That is, just write down, if y is equal to a cos nx plus a sin nx, prove that. Prove that y2 plus n square y is equal to 0. Will you try it first, then
So both sides are n. nx.
nx, cos nx, sin nx, right? Okay, this is not A, rather this is B. This is B. A cos nx plus B sin nx. Okay, fine. Let's do together. Differentiating both sides. Now, this is a very important statement. I mean, to do a sum or to write a sum, these two are completely different. Because most of the times we find as an examiner that the candidate is confident enough that he has done the sum. But he didn't express, he or she didn't express in the proper way. There is a proper format. There are some statements which has to be there. So, we write differentiating both sides with respect to x. We get dy dx. That is equal to cos minus a in sin nx plus b in cos nx. Normal differentiation. d2y dx2, I am to differentiate it for the second time. Sin ka differentiation cos and nx ka differentiation in. So minus a in square cos nx. This will be cos minus b n square sin nx. We take minus n square common, we get a cos nx plus b sin nx. And this is nothing but y probably, yes, a cos nx plus b sin nx. So is equal to minus n square y. Therefore, d2y dx2 plus n square y is equal to 0. Here also second time you have to write differentiating both sides with respect to x. Now basically I have done 1, 2, 3, 4 steps. And if you find difficulty in any particular step, please let me know. Is it okay?
Yes, sir.
Very good. Can I have it now? Next sum, the first part of it, we proved it in class, and it is considered to be a very, very important problem. And there are many types of this problem, and I have discussed that also. That is, x to the power n into y to the power n is equal to x plus y whole to the power of m plus n. You have to prove that d2y dx2 is equal to 0. If this is x to the power n into y to the power n is equal to x plus y whole to the power n plus n, prove that this is 0. Can anyone tell me, first of all, we have done this sum. Not only done this sum, I showed you how many different types of sums can be generated from this particular sum. And the result is almost as important as the formula. Can anyone recall what was the answer for dy dx?
So y by x.
Very good, y by x. I think we don't have to do that part once more, because we have already done this sum just few days back. So shall I skip that portion?
Yes, sir. That's fine.
Okay. So from here, by taking log, I am just writing the first step. Taking log m log x plus n log y is equal to m plus n log x plus y. Then, okay, what type of function is this? At this stage,
Implicit.
very good, implicit. You are in top form today. Implicit form, right? Absolutely correct. Then after 2-3 steps, I will be getting after simplification dy dx is equal to y by x. Now, second part, d2y dx2. Obviously, you have to differentiate second time, differentiating both sides with respect to x. The differentiate is around d2y dx2, and that is u by v square x into dy dx minus y into d dx of x, that is 1. What is dy dx? Y by x, I substitute that. X cancels. Y minus y is 0 by x square. Answer is 0. Is it okay? If you find any difficulty, please let me know. Can I have it?
Yes, sir.
Okay.